Professor Belfrost's science class is back.
Hi, welcome back to this channel. And today we'll again discuss another concepts related to science. So here's the science tutorial for you today. Are you ready? Let's continue playing this video. Okay, so this is the third lesson on chapter of function. Okay, welcome back. I think that our last lesson, oh yeah, we have done with this. Okay, the previous one describing sets on real number lines, and now we'll try to find domain range from a graph. Yeah, so another way to identify domain range of function is by utilizing graphs, and because the domain refers to the set of possible input values, so the domain of a graph consists of all the input values shown on the x-axis, and the rest is the set of the possible output. Okay, so range domain. Okay, range is a set of possible output values which are shown on the y-axis. And keep in mind that if the graph continues beyond the portion of the graph, you can see that the domain range may be greater. Okay, may be greater than the feasible values. Please pay attention to figure 8. So you can see what's the domain shown here. Yeah, the domain, if we cut from here to here, is about -5 to 5. It's not 5 actually, it's about 4.5. But how about the range? The range is from about 5 to -9. In this case, if we cut it through this portion, okay? But actually, because you see that this line is continuing, okay? It means that actually it will go into minus infinity, and also the domain is, yeah, you can say that the domain is also going to infinity positive. But actually, I think that this will not go not very great number, but it will approximately going to 5. I don't know if to write it as this. We just follow it, okay? So yeah, so the vertical axis of the graph is all range values 5 and below. So the range is minus infinity to 5. Okay. Okay, so example 6, finding domain and range of a graph. So find the domain and range of the function f. Okay, so this is function f. Okay, whose graph is shown in this figure. So you can see, please pay attention to this. We have this dot here, close dot, and this is open dot. I always say this is close dot or black dot, and this is white dot or open dot. Okay, so we can observe that the horizontal extent it is from -3 to 1, but you need to pay attention that this include 1, but this doesn't include -3. So you see that we use parentheses here and we use bracket here, so that's different. Okay, and the vertical extent of the graph is 0 to -4. Why? See, the y is from 0 to -4. It's the minimum value, so it is -4 comma 0. Why use this? Because you see this happens when, yeah, you understand it, right? And in example 7, find the domain and range of the function f whose graph is shown here. So yeah, for the domain is very easy, right? The domain is from here to here. Yeah, I cannot say for sure what is this. So yeah, it's maybe about, yeah, this book say this is about 9733 to 2008. Yeah, you can just approximate it, but I'm also not very sure about that. And the range is approximately, yeah, you can see a little less than 200. Maybe it's about 100. Yeah, this book say 180. Just, yeah, we just rely on this book, okay? Believe that this is true, correct, okay? And it is about more than a little more than 2000. This book say that this is 2010. We just combine this, okay? And I want you to give a try to this one. Next, find domain range of the toolkit functions. Okay, so yeah, this is the toolkit functions. For the horizontal line like this, it means that this is constant. So this is y equals some value. For example, if I write and this is 2 here, it intersects 2 in the y-axis. It means that f(x) is equals to. Where's the domain? The domain is minus infinity to infinity. Okay, and the range is the same. Okay, for all x value, the y remains the same. So it is the constant itself. For example, in the example that I told you before, is 2. Okay, how about this identity function? Identity function fx equals x. Okay, so actually, yeah, the domain is the same. It is minus infinity to infinity, and the range is, yeah, the same, because fx equals x, so the domain must be the same value with the range. So it's also from minus infinity to infinity. Okay, how about for absolute value? Absolute value is actually fx equals x, but we omit the minus sign, right? Okay, so it means that domain is also the same, minus infinity to infinity, but the range is what? It cannot go from minus infinity to infinity, because we have cut the negative portion, and we start from 0 to infinity, this part, and also this is 0 to infinity. Okay, from center to right, center to left, the range is the same. Okay, how about this one? This is a quadratic function. It is fx equals x squared. So the domain is again the same as infinity to infinity. But how about the range? The range is, you see, you will never gain uh, a lesser value than 0. So 0 to infinity. But this is for quadratic function with this form, yeah. If we are, for example, we manipulating it, for example, fx equals x squared minus 2, it means that the range will start from minus 2 to infinity. Okay, this is just for the form that is shown, the spatial form that is shown, the toolkit form that is shown in this book. Okay, how about the cubic function, the basic cubic function fx equals x cubed? The domain is also again minus infinity to infinity, and the range is, yeah, the same, is minus infinity to infinity, because actually is for all odd function, this is odd function, and this is what called even function later. For all odd function, the range must be the same domain. Okay, how about the reciprocal function, or 1 by x? Oops, I'm sorry. Let's skip it fast. So actually, it's the same. You see that the domain never cuts on 0. Okay, you see it never past 0. It never touch 0. So what can you conclude from this? Okay, what we can conclude is, for sure, it never cuts 0, but it will nearly reach 0. Okay, so it goes from minus infinity to near 0, union 0 to positive infinity. That's how we say this. This is the domain. How about range? The range never goes below 0. So 0 is the minimum value. So 0 to infinity. Great. Now let's go. How about reciprocal? Oh, I'm sorry. This is a reciprocal function. This is a reciprocal cube function. Okay, a square function. I'm sorry. This is for reciprocal square function. Reciprocal cube function, because I'm sorry. For reciprocal function, the domain remains the same, because why? Yeah. Once again, it is odd function. Every odd function, the result of the domain range is the same. But for the cube function, not odd, even function, not cube, even function, the range is just half the domain. Okay, that's actually what we really need to keep in mind, and the others is just left it. Okay, okay. So next, figure 20 actually is kind of awful. The arrangement, I really don't like this. Okay, so the next one is for the square root function of fx equals square root of x, that we cannot take the square root of a negative. This is very important. Okay, you pay attention to this. We cannot take the square root of a negative real number, so the domain must be 0 or greater. And because this is 0, the minimum value of the square root of 0, this is the minimum value, is 0. So yeah, the rest is once again minimum value is 0, and it goes to infinity. Okay, how about this, the cube root function? Also, because it's a cube root, then the domain and the range is the same. Okay, because this is odd value, odd function. I mean, not odd value. Okay. Now, given the formula for a function that determines the domain and range by following these four steps. It's very sensitive. Okay. So yeah, you see, yeah, these four steps. Okay. Now let's start investigating it. Yeah. Find the domain range using two functions. We find the domain range of fx equals 2x squared, 2x cubed minus x. So what we need to do to solve this one? Hmm? Actually, you can identify them separately. This is one function. Oops. Actually, this function actually consists of two expressions, 2x cubed and minus x. So this is an independent first function. This is the second function. We need to find the restriction of the first function and the restriction of the second function. For the first function is that it has no restriction, okay, of the input or the domain, as well as the second function. Okay, so the domain is from minus infinity to infinity. Okay, intersect minus infinity to infinity. Okay, yeah, both have the same domain. So you just pick one. So minus infinity to infinity. How about the range? The range is the same. Okay, it can goes from minus infinity to infinity. So it's actually very simple. The next thing is the next example is find the domain range of fx equals 2 by x plus 1. Okay, so yeah, you see this is a rational function. Okay, this is a rational function. It means we have numerator by denominator. Okay, and you see that the denominator x plus 1 cannot be evaluated if this function cannot be evaluated if the denominator goes 0. So x plus 1 should never be 0. So minus 1 is the exclusion. Okay, because it makes the division by 0 will be undefined. So the domain must be minus infinity to minus 1, union minus 1 to infinity, positive infinity. And because the function is never 0, then we should exclude 0 from the range. Okay, so the range is from this. Okay, minus infinity to 0, union 0 to positive infinity. The next example, okay, find the domain range of x equals 2 times square root of x plus 4. So we again cannot take the square root of a negative number, so x plus 4 must be greater than or equals 0. This is the one that is presented in this book. Okay, so x is greater than or equals minus 4. So the domain of fx is, you see this, the beginning is bracket, but the closing, is parenthesis. Okay, so because we have this, okay, we have this greater than or equal. So greater than or equals means start equal, so it include, but the infinity never have an include sign. It will exclude. Okay, infinity is not a number. Okay, so minus 4 comma infinity, positive infinity in this case. Okay, and we then find the range, and we know that f minus 4 it is 0, so it must go from 0 to infinity. Very easy, right? Okay, so this is the figure for the function above. Then I want you to try to solve this. This is actually a very easy one. Now graphing piecewise defined function. Okay, um oh yeah, the piecewise function, take for example absolute value function, fx equals absolute x. Okay, so with a domain of all real numbers that range of that is greater than or equal to 0, the absolute value can define as the magnitude or modulus of a real number regardless of sign. Is it from 0 to the number line? All of the definition require the object to be greater than or equals to 0. So yeah, you see it's like this. And because this requires two different processes of pieces, that the absolute value function is an example of example, piecewise function. So a piecewise function is a function in which more than one formula is used to define the output over different pieces of the domain. Okay. So you see, we notate the idea of piecewise function to be like this: fx equals, for certain cases, we apply formula 1. Okay, if x is in the domain 1. For certain domain, domain 2, it applies formula 2. For domain 3, we apply formula 2. Okay. So if you are given a piecewise function, then you can identify the domain for each interval by using the 3 steps that I have highlighted for you. Okay, for example, a museum charges $5 per person for a guided tour with a group of 1 to 9 people, or a fixed $50 of V for a group of 10 or more people, and write a function relating the number of people and the cost C. Okay, so yeah, you can see two different formula will be needed. So for n values under 10, the C equals 5n, n is the number of people. And for n greater than or equals 10, then the C is constant 50. And you can plot it like this. Easy, right? Next example, a cell phone company uses the function below to determine the cost C in dollars for gigabytes of data transfer. So this is the function, the piecewise function, I mean. So find the cost of using 1.5 gigabytes of data and the cost of using 4 gigabytes of data. So we have two conditions we need to analyze. The first one is if G equals 1.5, and the second one is G equals 4. So for G equals 1.5, it is under this condition, right? It is between 0 to 2, right? So the cost is 25. But for 4 gigabytes, it is, okay, we use this condition where G is greater than or equals 0. So 25 plus 10 times 4 minus 2. 2 times 10, it is 20, 20, 25, $45. It's easy. And you can see this is the plot of the graph of the previous example. Okay, and this is the way that you can plot the graph above. Okay. This is a sketch of a graph. Actually, this is easy, right? Actually, you just need to sketch piece by piece, and then you just need to combine them together into one union, one final function, one final graph, I mean, okay? Okay, maybe I'll go a little further. Rate of change, okay? Discuss a bit about rate of change. So gasoline cost of experience, this is a fluctuation shown. Yeah, finding the average rate of change of function. So the price change per year is a rate of change because it describes how. So rate of change is how to describe how an output quantity changes relative to change in input quantity. Okay. So if we use only the beginning and ending data, we will be finding the average rate of change over the specified period of time. Okay. So this is the same. So finding slope, right? Okay. So yeah, delta is a Greek letter, the third Greek letter, and the fourth Greek letter. Okay, this is the capital delta. Okay, the not capital delta is not written like this. I don't know how to write it here. Okay, it's like something like this. Okay, this is delta y. So this is red delta y over oh yeah, this is y delta y. Y divided by the change in x. Okay, occasionally we write delta f instead of delta y, which they represent the same meaning. Okay, for example, for this one, from 2005 to 2012, okay, the rate of change is 3.68 minus 2.31. It is about 1.37 by 7. Is about this. Okay, so rate of change can be calculated using this formula. So let's solve this problem using the data in table 1 for the average for the price of gasoline between the 2007 to 2009. This, right? This 3. So 2.41 minus 2.84 is minus what? Minus 4 minus 0.43, right? By 3, right? A by 2, I'm sorry. So this is easy actually. The next example, we will finalize this section, okay? Compute average rate of the change form of graph. So find the average result of change on the interval minus 1, 2. This is the domain, okay? Once again, this is domain, and what we find is the average rate of change of the range, okay? The range that apply this input or this domain. So minus 1 to 2. Minus 1, how much is this? It's about 4. How about 2? It's about what? So 1 minus 4, it is minus 3 by 2. Minus 1. Example 3. This one. So the first 6 hours. So 1, 2, 3, 4, 5, 6 is this or this or this 6 hours. Start. Yeah, 6 minus 0 is the meaning. So 292 minus 10, so 282 by 6 is 47. Okay, next example, actually the same. We need to find first. For this, we need to substitute the beginning of the interval and the end value of the interval through the function to find the range first. So it's from 7, not the range, I mean the output, the function result. Okay, so this is 7 halves and 3 quarters. So 63, I mean 63 quarter minus 7 halves by, okay, divided over 4 minus 2. Easy. 49 by 8. 49 over 8. 49 eighth. Example 5. Actually, it's the same. Easy. Okay. We just substitute it and process it as it should be. And also for this is, yeah, actually it doesn't, yeah, we just substitute a to the value. This is not a direct number, but it still can be done. Now, yeah, this is our last one. So we need to solve it by using, yeah, this is the assignment. Okay, I think it's okay till here. So yeah, I want to share a very good quote for you today. Lao Tzu once said, "Mastering others is strength, mastering yourself is true power." That's the end of the video for today. Thanks for watching, thanks for following so far. And here's what you need to do. Please subscribe, give a thumbs up, comment, and share this video to your friend. And also, don't forget to check our website, https://